Hey everyone, welcome back to the channel where we break down maths topics the easy way. Today we're diving into something that pops up all the time in GCSE maths, surds. If you've ever wondered why teachers insist on leaving answers with a square root instead of just writing the decimal, you're in the right place. We'll go through what a surd is, why we use them, the key rules you need to know, and step-by-step examples so you can actually use them in any question. To start off with, what is a surd? A surd is basically a root that can't be simplified into a whole number. This makes it an irrational number, meaning it can't be written exactly as a fraction, and its decimal goes on forever without repeating. For example, the square root of 5 is approximately equal to 2.236, but it actually goes on forever. This means that the square root of 5 is a surd. On the other hand, the square root of 4 can be easily written as 2, which means the square root of 4 is not a surd, it's just 2. We keep surds in root form because that's the exact value. If we use the decimal, we'd only have an approximation. So we keep surds as a surd to avoid rounding errors and to maintain accuracy in calculations. For example, imagine you're doing a big calculation with the square root of 2. If you rounded it to 1.41 and then multiply, divide, add, subtract, square it in a calculation, the error margin grows. However, if you keep it as the square root of 2 until the very end, your answer is perfectly accurate, which is why we use surds where we can. Now, before we jump into the examples, let's take a look at the main surds rules you'll use again and again. The first one is simplifying surds. And the way you do this is by breaking down a number into its factors and looking for perfect squares. For example, if we wanted to simplify the square root of 12, we could write this as the square root of 4 times 3, which is the same as the square root of 4 times the square root of 3. As we saw before, the square root of 4 is 2, and so this simplifies to 2 root 3. Note, 3 is not a square number, so it cannot be simplified, which is why we leave it in its surd form. The next rule is addition and subtraction of surds. Only like terms can be combined. For example, 2 root 3 plus 5 root 3 can be combined to 7 square root of 3 because the coefficient in front of the surd are added as long as the surd itself is the same for both. So as long as what I've marked in blue is always the same for both parts, you can add them. Sometimes you might need to simplify it. For example, if we had the square root of 12 plus 5 root 3, this would give us the same answer because as we saw above, the square root of 12 is equal to 2 square root 3. However, if the base number is not the same, you cannot add and you cannot subtract. Next, we go on to multiplication. A general rule for surds is that the square root of a times by the square root of b is equal to the square root of a times b. In other words, you times the numbers underneath the square root sign together. For example, the square root of 2 times by the square root of 3 becomes the square root of 6 because 2 times 3 is 6. If your surd has coefficients in front, for example, 3 square root 5 times by 2 square root 3, you times the coefficients together, so 3 times 2 is 6, and you times the number inside together, so 5 times 3 is 15, and you get 6 times the square root of 15 as your final answer. If you're squaring a surd, this is a special case, as the square root of a times by the square root of a is simply a itself. For example, the square root of 7 times by the square root of 7 gives you 7. This is a nice way of making surds into a rational number. Now, division of surds works quite similar to multiplication, in that if you do square root of a divided by the square root of b, this is the same as the square root of a divided by b, much like multiplication worked. You could also write this as root a over root b is equal to the square root of a over b. For example, the square root of 8 divided by the square root of 2 is the square root of 8 divided by 2, which is the square root of 4, which as we saw earlier is 2. This is another way that we can simplify surds. Our final rule is rationalising the denominator. A general rule of thumb is that we don't like surds on the bottom of a fraction. So the way you get rid of it is by multiplying the top and the bottom by the surd itself. So here we times the top and the bottom by the square root of 3. This makes the top 5 times root 3 and the bottom is root 3 times by root 3, which as we saw before, when you're timing surds together you get 5 times the square root of 3 divided by the square root of 3 times 3, which gives us the square root, 5 times the square root of 3 divided by 3, which you could also write as 5 over 3 times the square root of 3, depending on what's easier to you. But notice we don't have a surd on the bottom anymore, which is what we're trying to do when rationalising the denominator. Now, let's see these rules and actions using some examples. For example, to simplify the square root of 18, we can write this as the square root of 2 times 9, as 2 times 9 is 18. This is the same as the square root of 2 times by the square root of 9, which simplifies down to 3 times the square root of 2. As 3 times 3 is 9, and so the square root of 9 is 3. Now let's multiply 2 root 3 with 4 root 5. So first we will do 2 times 2, which is 8, and then the square root of root 3 times root 5, which is root 15. And that's our final answer. Our next one is addition. 5 square root 7 plus 2 square root 7. We add the numbers outside of the square root because the number on the inside are the same. So 5 plus 2 is 7 and the number inside stays the same. So we get 7 root 2. Let's now look at division. We've got the square root of 50 divided by the square root of 2. And from our division rules, we know this means we have to do the square root of 50 divided by 2, which is the square root of 25, as 50 divided by 2 is 25, which makes it the answer 5, as the square root of 25 is 5. Finally, let's rationalise this denominator, which we saw previously. We'll times both the top and the bottom by the square root of 3. This gives us 5 root 3 divided by root 3 times by root 3, which, as we saw earlier, gives us the square root 5 times the square root of 3, all divided by 3. And there we have it, some key examples of how the rules of surds are used and how you can use them in a question in the future. And that's everything you need to know to get started with surds. What they are, why we use them, the golden rules, and an example for each. If you learn these now, questions with surds become very straightforward and you'll save marks in the exam. If this helped you feel more confident about surds and how to use them, Hit the like button, subscribe for more walkthroughs, and drop a comment below if there's a topic you'd like for me to cover next. You've got this. See you in the next video.